Why is the DoD opining on the climate? I'm not sure how many tanks, naval ships, fighter jets, or nukes will save us from a changing climate. If the war in Ukraine is any indicator, military overtures will only accelerate climate change and hurt millions, if not billions, of people. Imagine a scenario where a country invades another on the pretense of failures to protect the planet by contributing to global warming. Unfortunately, this scenario is not difficult to imagine. For some reason, the most likely outcome with regards to climate change is being overlooked and overshadowed by the most extreme scenarios, removing from the table any rational discourse or sane public policy initiatives on the topic. Climate alarmism leads the digital tabloids and has infiltrated the minds of powerful people in national and global decision-making positions. It is unlikely these people actually looked through the 4,000-page report from the IPCC or vetted any of the media or the policy advisors' claims. Most of the world's major issues have extremists on both sides, with the truth usually sitting somewhere in between. There are people that willingly choose to deny the observations and data that indicate the climate is changing, disregarding the science as a farce. It was difficult, however, to identify people in positions of power that openly claim climate change is not real. Donald J. Trump was one of those powerful people, but he no longer sits in the White House and has very little influence on decision making. Whereas it was not hard to find the opposite extreme, where powerful people say, "We are all doomed." Rather than rely on the most vocal activists and antagonists, let's look at the data on climate change and see what is really going on. To best understand climate, we must recognize that planetary science is very complex, and only in the last 80 years or so have we had reliable recording instruments to measure physical phenomena that impact atmospheric, terrestrial, and oceanic conditions. All other previous time periods had their conditions reconstructed from analyzing naturally occurring ice cores, corals, marine and lake sediments, mineral deposits and caves, tree rings, temperatures, soil, fossils, and even artificial boreholes. In addition, climate must be understood in the proper context by analyzing trends over decades and preferably hundreds of years. We cannot simply link a direct cause of climate variability from year-over-year changes. Scientists have plotted out several possible scenarios for average global temperatures over the next 80 years. These different lines represent socio-economic pathways or temperature increases, with some lines having a greater probability of reflecting actual conditions than others. RCP 8.5, or the dark red line, is the most extreme case, suggesting temperatures will rise roughly 11 degrees Fahrenheit or 5 degrees Celsius. This is the scenario climate alarmists tend to hold close, but it is actually the least likely to occur. The most likely outcome is SSP 1-2.6, the dark blue line, which indicates a roughly 4 degrees Fahrenheit or 2 degrees Celsius increase in temperatures. Using historical and NASA satellite observatory data, we can witness that the average global temperature has increased roughly 1.9 degrees Fahrenheit since 1880. Any temperature recordings beyond 1880 are somewhat or fairly unreliable. Looking at the simulation, we can see that not everywhere experiences the equivalent warming, with the North Pole seeing a much more substantial rate of warming, while the Pacific has actually remained relatively unchanged. Meanwhile, some areas such as the part of the South Pole are actually cooling, indicating just how complex climate science really is. Overall, though, we can see the planet as a whole is warming. If we acknowledge this expected level of warming over the next 80 years, estimates indicate that a roughly 2% global increase in land precipitation relative to 1995 will occur, and sea levels globally will rise roughly 0.4 meters or 1.3 feet. Neither of these outcomes are earth-shattering, and we can adapt fairly well to these changes. In addition, other unexpected changes could either exacerbate or counter the causal mechanisms for these outcomes. There are simply unknown variables that can play a major role and influence outcomes. Scientific evidence attributes this warming to a specific mechanism referred to as the greenhouse gas effect. The greenhouse gas effect relies on molecules called carbon dioxide, methane, nitrous oxide, and water vapor that all trap infrared radiation. Most of the light from the sun have a wavelength that falls under the ultraviolet radiation or UV light portion of the electromagnetic spectrum. Because of this wavelength, a percentage of it is able to pass through the atmosphere, smacking the rocky surface and ocean waters. When this UV light hits the surface, some of it is repelled back up towards the atmosphere with a different wavelength called infrared radiation. With this wavelength, much of it cannot escape the grip of greenhouse gases and then becomes trapped. Once trapped, it creates additional heat that would otherwise have dissipated into space. This mechanism is a bit more complex than many would have you believe, and the GHG cycling or heat impact is still not fully understood due to lack of testing sites, but there is adequate evidence for the existence of the mechanism. Now that we know how GHGs work, the most influential culprit is carbon dioxide, because unlike water vapor, there is no cap on its heat trapping ability, and humans are pumping massive amounts of it into the atmosphere. We have been reliably measuring the amount of carbon dioxide in parts per million in the atmosphere since 1958, which is represented by what is called the Keeling curve. The trend upwards is clear, and the annual scissoring is thought to be the result of seasonal carbon dioxide uptake due to photosynthesis in the summer and losses in the winter. To add even more context, using ice core data, we can see that carbon dioxide concentration is at unprecedented levels in the last several million years. If we continue on this trajectory and double the concentration of carbon dioxide to 1,000 parts per million, based on known physics and observations, the density and robustness of vegetation should increase. Ocean acidification will create a cascading change in ocean chemistry, altering the environment for fish. And humans will have to adapt to different precipitation patterns, flooding coastlines, seasonal changes, and changes to fertile lands for agriculture, resulting in a slow migration of millions and millions of people. All of these changes are part of a dynamic system that will have both negative and positive impacts for a diversity of different species. It is hubris to think we can control it all, and that a different path would have been more prosperous had we not burned fossil fuels. Evolution is relentless and will continue whether we exist or not, causing mutations and adaptations for life forms in an ever-changing world. Globally, humans obtain 90% of their energy, or 140,000 terawatts per hour, from traditional biomass and fossil fuels such as gas, oil, and coal, which all release carbon dioxide as a byproduct into the atmosphere and oceans. Chances are, anything that you own that uses electricity, such as dishwashers, shower heads, your computers, dryers, stoves, ovens, electric vehicle chargers, air conditioners, refrigerators, and so on, will have its power sourced from fossil fuels, with only a 10% chance of it being a form of renewable energy or nuclear energy. Due to their many limitations, it is not possible to maintain current lifestyles and rely on renewables to provide enough energy in a geographically dispersed manner. Plants and trees feed on carbon dioxide, but when they burn in wildfires or in any fire, they release that carbon dioxide back into the atmosphere. Oceans also absorb carbon dioxide, but this will have a detrimental impact to cities near coastlines because this captured carbon dioxide causes thermal expansion of the oceans, whereby excited water molecules take up a greater volume of space. Higher temperatures towards the North Pole are also causing ice caps to melt, which in turn adds more liquid water to the oceans. We have experienced an increase of approximately 1 foot to the mean global sea level over the last century and expect a similar or slightly more than that over the next century. Sea level rise is not inherently bad, except for the fact that 8 of the 10 largest cities in the world sit near coastlines, and if inundated with water, would cause mass migration and a displacement of families and communities. Adaptations and resources would be required to accommodate this dispersed population, but it is something that will probably not directly result in death. All of these physical processes will result in outcomes that are both predictable and unpredictable. Certain land areas will benefit and prosper, while others may flood or be more difficult to grow crops on. For example, record high temperatures are not increasing at an alarming rate, while record low temperatures do occur less frequently, hinting at a more mild climate that has less deep freezes without significantly more heat waves. Only time will tell if this pattern will prolong. One area that may be of shock and antithetical to popular media: there is little evidence suggesting climate change is inducing more frequent and more harsh extreme weather events, given the warming we have witnessed over the past century. In fact, there is actually evidence suggesting the contrary. Damage associated with extreme weather events as a percentage of GDP since 1990 is flat. Deaths from extreme weather events have actually dropped 98% over the last 100 years. Land burned globally has decreased since 2003. The increase of recorded tornadoes are attributable to dedicated storm chasers and better recording devices such as radar that can capture EF0 tornadoes, the least dangerous vortex. And hurricane frequency globally has decreased. We know the climate is changing. We know that quality of life has only improved thanks to warmer temperatures and new technology that uses energy. We know decreasing temperatures or an ice age could be comparatively more harmful. We know fossil fuels, regardless of their climate impact, release harmful particulates that kill millions of people. Therefore, we should continue to innovate and cultivate new technologies, including sustainable energy production. We should explore space and inhabit other planets to become a multi-planetary species. And most of all, we should continue to live life to the fullest.